So in finance, whenever we are dealing with the portfolio construction, we deal with the n assets instead of one asset, in single asset. And in this kind, we use the returns, log returns of these n assets. And this is known as RT. Given n asset, this is the log return vector of this n assets. And again, in this case, depending on our horizon, this index t can denote an arbitrary period. So if we are interested in daily one, then each t here, whenever we are measuring the log returns against, will be daily log returns. But in another cases, so we may be interested in weeks, whereas this time t and t plus 1 will, the difference between t and t plus 1 will show a week difference, and the log return will show a weekly log return difference. And similarly, for high frequency data, we have here a 5-minute interval, for instance. This is an example. And in this case, t and t plus 1, the difference between them will be a 5-minute interval. And again, in this case, we assume that there is a mean, depends on the time in most general case. And the mean is basically an expectation of these returns of the asset, given all the history, and the covariance matrix, which is basically the covariance between different assets. So this is covariance matrix, which is the covariance between different assets. And in finance, we'll use this covariance matrix as the risk of the selected number of assets. And in this case, it's basically covariance of the returns, and given that the history of the historical data. In this case, given historical data, the covariance is basically returns minus mean times return minus means transpose. And in this case, this will be a n times 1. So this will be n times 1 vector, and its transpose will be 1 times n. And the resulting matrix, covariance matrix, will be n times n. And the mean here will be n times 1, because the returns of all assets are n times 1. And we assume that the model is IID model, which is basically independently identically distributed. And even though this is not general, that's what we assume this is the case. And in this case, previously, the return distribution or the covariance distribution at each time t may have been different, and it was depending on the historical data. But if we assume that the model, our model is basically IID model, then basically both the conditional mean and the conventional covariance is constant. So in this case, for portfolio optimization, we'll use this model. So we'll assume that for many cases, the mean and the covariance matrix is basically constant across time. Portfolio optimization